Hi, this is Andrea Hendricks, and I want to talk to you some about applications of quadratic equations. One of the applications that you're going to have to deal with involves the right triangle. And let me just remind you of the right triangle and a formula that you hopefully know. In a right triangle, if we label the sides A, B, and C, where A and B are called the legs, and C is called the hypotenuse. Do you remember the Pythagorean theorem that states that a squared plus b squared is equal to c squared? So we're going to use that in this problem. The problem says that a 13-foot ladder is leaning against a house. So if you kind of get the picture of what's going on, here's your house. You have a 13-foot ladder that's leaning against it. The distance from the bottom of the ladder to the house, so we're talking about this distance here, is 7 feet less than the distance from the top of the ladder to the ground. So here is that distance. So if the distance from the bottom is 7 feet less than the top, if we call this x, then 7 feet less than that has to be x minus 7. It says how far is the bottom of the ladder from the house? So we need to find this distance here, x minus 7. Assuming the ground is level, we're going to have a right triangle application. Pythagorean theorem is a squared plus b squared equals c squared. So we'll have x squared plus x minus 7 squared is equal to 13 squared. And then the most common mistakes I have in these problems is not squaring the binomial correctly. So just keep that in mind as you go through the problem. X squared is obviously x squared. X minus 7 squared is x squared minus 14x plus 49, and that's equal to 169. Putting it in the standard form of a quadratic equation, we can combine like terms, get one side to 0. Here's another common error. X squared plus x squared is 2x squared, not x to the fourth. Remember, we only add exponents when we're multiplying like bases. 2x squared minus 14x. We have to subtract the 169 from both sides. That will give us minus 120, and that's equal to 0. So now we need to solve this in various ways. We could either factor it or use a quadratic formula. What I'm going to do to make it easier to solve is notice that there's a common factor of 2. So if you divide every term by 2, we get x squared minus 7x minus 60 is equal to 0. And now this trinomial is a little bit easier to deal with. We can find the factors of 60, whose difference is 7, and that's going to be 12 and 5. And again, if you don't like factoring, you can plug into the quadratic formula with a being 1, b being negative 7, and c being negative 60. But if we use factoring, if the last sign is a difference, they have to be different signs with the middle one negative, or the larger one negative. So then we get that x minus 12 is equal to 0, or x plus 5 is equal to 0. So x is either 12 or x is negative 5. Since we're in the context of a real-life application, we can't have a negative value for x because we can't have a negative length to the side of a triangle. So that means x is 12. So 12 is the distance from the bottom of the ground to the top of the ladder, but the distance from the house to the bottom of the ladder is 12 minus 7, or 5 feet. Okay. The next problem, still a geometric application. This one is dealing with a swimming pool that's 30 feet wide and 40 feet long. An exposed aggregate border in a strip of uniform width is put around the pool. They have enough material for 296 square feet, that is, to do the border around the pool. How wide can the strip be? So you have to think a little bit creatively here to get the idea of what's happening. we have a pool that is 30 feet by 40 feet. And around that pool, we're going to put a border. Okay. Now, the thing about the border is it says it's of uniform width. So that means, let me change my color here. Oh, it's not letting me. Oh, well, forget about that. um, if it's the width is what we need to find, we're going to let x be the width of the strip. So that means that this is going to be x, the distance here will be x, the distance here is x, and the distance here is x. Okay? Since we know we have enough material for 296 square feet, that's talking about the area of the border is equal to 296. Well, the way that we can get the area of the border is that we have to do the whole area of this new figure minus the area of the pool, and that will leave just the border. So we're going to have to do total area minus the area of the pool, and that will equal the border's area. Okay. Well, what is the total area? That means we need to find this dimension out here. Well, it was originally 40, right? But we expanded it by x on each side. So this is 40 plus 2x. The width here was originally 30, but we expanded it by x on each side. So this is 30 plus 2x. Now the area of the pool we already know is 40 times 30, right? Just length times width. So we're going to put it in the formula 40 plus 2x times 30 plus 2x minus 40 times 30, and that's going to equal to the area of the border, which is 296. Okay? So if we multiply these binomials, we get 1200 plus 80x plus 60x plus 4x squared minus 1200 is equal to 296. So let's put this in standard form. So we have 4x squared. The x terms combine to give us 140x. Notice the 1200's at to 0. And then we can subtract 296 from both sides to get minus 296 equals 0. Now here again you have some options about how you can solve this. I've noticed that 4 goes into each of those numbers. So if we divide by the common factor, we get x squared plus 35x minus 74 is equal to 0. And you just need to try that. Try with whatever coefficient is on the square term to see if it goes into each of the others. If it doesn't, then maybe look for a common factor of a 2 or something of that nature. And now I need to find the factors of 74, whose difference is 35. Again, if I want to do this by factoring, I could always go back to the quadratic formula. But if I think about what are the factors of 74, we get 1 and 74, 2 and 37, and those have a difference of 35. So I can put this in my factored form to be x and x, 37 and 2. The signs are different, larger one's positive. So this tells us that x plus 37 is equal to 0, or x minus 2 is equal to 0. So that gives us either x to be negative 37 or x to be 2. And so the negative 37 can't work because that's a length of a border. So our border length or width would have to be 2 feet. Okay. Now, another application you're going to deal with is the height of an object. It says a rocket is launched from ground level. Its distance in feet from the ground in t seconds is given by d of t, which is equal to negative 16t squared plus 208t. At what times will the rocket be 550 feet from the ground? So to solve this problem, we have to understand we're trying to find time. We know what the height from the ground is. And that's exactly what d of t represents, right? It's distance in feet from the ground. So we're going to replace d of t with 550 and solve this equation for t. Now we need to get it in standard form. So if we add 16t squared, subtract 208t, and then the 550 stays, that's equal to 0. And here again is maybe one that we can reduce a little bit. I think between 16, 208, and 550, the common factor of those numbers is just a 2. So we can reduce this down to 8t squared minus 104t plus 275. And that's equal to 0. Now this one would be one that would be kind of tricky to factor. In fact, I don't think it factors. If I do 8 times 275 and look at the factors of that number whose sum is 104, you're going to find that there's not any numbers that work. So we're going to have to use the quadratic formula for this one. So to use the quadratic formula, we're going to have to say that a is 8, b is negative 104, and c is 275. Okay, so remember the quadratic formula is the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So we get t is equal to the opposite of negative 104 plus or minus the square root of negative 104 squared minus 4 times 8 times 275. And that is all over 2 times 8. So the opposite of negative 104 is going to be positive 104 plus or minus the square root. Let's see if we can find this number inside the radical. So if you use your calculator and enter negative 104 squared, which is going to be positive, minus 4 times 8 times 275, we get 2016. And that's all over 2 times 8, which is 16. So let me get to the next screen here. We have really that t was equal to, what was that, 104 plus the square root of 2016 over 16, or t is equal to 104 minus the square root of 2016 over 16. So for these problems, we need to approximate what that value is. So the best way to do that is to enter 104 plus the square root of 2016, close the parentheses and press enter, and then divide that number by the denominator of 16. So you should get 9.3 approximately. Okay. Or the other value, we enter 104 minus the square root of 2016, enter, and then divide that number by 16. Or the other value is about 3.7. So understand what's happening. This rocket has been launched from the ground, and it goes up like this. When will it reach a height of 550? It's going to reach that in 3.7 seconds and in 9.3 seconds. So in other words, when it's going up and then on the way back down, it will reach that height again. So there can be 2 answers for this particular problem. Now, one more thing with this height type of problem, you may be also asked to find when will it reach the ground. And the trick to that one is to know that at the ground it is 0 feet from the ground, so the distance or height of the object there is 0 feet. So we could say our formula, which was what, negative 16t squared plus 208t, and set that equal to 0 and solve. And in that case, you can look for a common factor or something between negative 16 and 208. 16 actually that goes into each of those. So if we take out a negative 16t, that will leave a t minus 13 is equal to 0. So we would say negative 16t is equal to 0, or t minus 13 is equal to 0, to give us t is equal to 0, right, when we divide by negative 16, or t is equal to 13. So when will it hit the ground? Well, it started at the ground, right? That's at 0 seconds. But then it takes 13 seconds after launching to return to the ground. Okay? So these are the application problems that you should be familiar with. Get practice on these, and if you have any questions, please contact me. Thank you.